HDL, it has also a hydrophobic core formed by mainly cholesterol ester and hydrophilic cell. Okay, so HDL, its name suggests high density lipoprotein. Why its density is high? Because of maximum protein content. If the protein content, your lipoprotein is mainly formed with your lipid plus protein. If the protein content of the lipoprotein is high, then its density is also high. If the lipid content of the lipoprotein is high, then the radius of the lipoprotein is also high. So now in this case, your high density lipoprotein, it has higher protein content or maximum protein content. Okay, that's why your density of the HDL is high. If the protein content of the lipoprotein is high, then density of the lipoprotein is also higher. If the lipid content of the lipoprotein is high, then radius or size factor of the lipoprotein is higher. So density is also denoted by your rho, which is like the English alphabet P. So just remember with this mnemonic, P and rho similar look. Okay, if the protein P for protein is higher in your HDL, then obviously also your density is also higher. Now when I am talking about the protein of lipoprotein, this is obviously your apoprotein. So the protein component of your lipoprotein is apoprotein. Okay, your HDL, it has apoprotein A1, okay, also apoprotein C, also apoprotein E. Okay, so those are the mainly the protein component or the apoprotein component of your HDL. Okay, and also I told that the HDL, it's least lipid present. When I am talking about the least lipid present in the HDL, then obviously HDL has lesser diameter or lesser size. Okay, less size, because I told that the protein content proportional to density of lipoprotein. And I also told that lipid content proportional to size of lipoprotein. Okay, so if the protein concentration or protein content is higher, then the density is high. Lipid higher, then the radius or size of the lipoprotein is high. So in case of high density lipoprotein, you can say that say that the protein concentration or protein content is high, that's why its density is higher, and less lipid content, that's why its size is lower. And phospholipid is maximally present your in HDL. You can see here phospholipid, which is a polar substance. Phospholipid, it's a polar substance which actually present along the periphery of the HDL. Okay, hydrophilic periphery. And one thing, the ApoA1 protein is also present in your HDL. Why I am telling this ApoA1 separately? Because it has one important role in reverse cholesterol transport. Your ApoA1 protein is actually activating one enzyme called LCAT. I'll tell this thing also later detail. Your ApoA1 is present, which is activating your LCAT enzyme, okay, and causing the and forming the cholesterol, the polar cholesterol, into the non-polar hydrophobic cholesterol ester. Okay, so let's discuss this thing. Here I am going to talk about the enzyme activity of the HDL. Okay, the enzymatic action within HDL. Okay, so here you can see HDL, it has two enzymatic activity. One, LCAT activity. Okay, another one, CETP activity. Okay, LCAT activity and CETP activity. So first of all, what is LCAT? LCAT, L for lecithin cholesterol acyl transferase. Lecithin cholesterol acyl transferase. Okay, and what's about CETP? Cholesterol ester transfer protein. Cholesterol ester transfer protein. Okay, when I am talking about the LCAT, this is your lecithin cholesterol acyl transferase. Actually, your LCAT enzyme is forming or converting the cholesterol into cholesterol ester, or it's better to say that polar cholesterol, hydrophilic cholesterol into cholesterol ester. I already told that cholesterol is converted into cholesterol ester after reacting with your fatty acid. I told this thing that, yes, here I think, yes, when cholesterol is reacting with fatty acid, it's converted into your cholesterol ester, and this is your hydrophobic substance. This is your hydrophobic substance. Or so here is your cholesterol. You can see here is your cholesterol. Okay, here is your cholesterol, and this cholesterol is reacting with lecithin. This cholesterol is reacting with lecithin. You can tell this lecithin is also known as what? Phosphatidylcholine. Everybody knows that. And what happens? This lecithin is actually giving a fatty acid moiety, and this fatty acid moiety is reacting with cholesterol. And already I told, when cholesterol is reacting with fatty acid, it is converted into hydrophobic cholesterol ester. Okay, so here what is the function of this lecithin? Here lecithin just it acts like a fatty acid group donor. Okay, so cholesterol reacting with lecithin in presence of LCAT enzyme. LCAT is lecithin cholesterol acyl transferase. Yes, you can see this thing here. Your acyl, that means it's indicating fatty acid. It is actually fatty acyl. Okay, so your LCAT, it's actually doing what? Transforming one fatty acid group from lecithin to cholesterol. That's why this is called your lecithin cholesterol acyl transferase, or lecithin cholesterol fatty acid transferase. Lecithin cholesterol acyl transferase. Why? Because this enzyme is helping to transfer one acyl group from lecithin to cholesterol, and then forming your cholesterol ester. This is that cholesterol ester which is your hydrophobic chemically, and this is present within the core of your lipoprotein. It may be your high density HDL or high density lipoprotein. And now what is the fate of this lecithin? Lecithin, after transferring one fatty acid to cholesterol, it is converted into lysolecithin. This is your lysolecithin, this one. Okay, so let's talk about the summary of this reaction. This is nothing but there is your cholesterol, there is your lecithin. This is also called your phosphatidylcholine in presence of LCAT. What is LCAT? Lecithin cholesterol acyl transferase. It is converted into cholesterol ester and lysolecithin. Okay, so cholesterol is reacting with lecithin. Lecithin is transferring one acyl group or fatty acid group to cholesterol and converted this cholesterol into cholesterol ester, and lecithin itself converted into lysolecithin. Okay, so this is one enzymatic activity within HDL performed by your LCAT enzyme. Okay, so here the cholesterol, it is your polar hydrophilic and present within the periphery of the lipoprotein, towards the periphery of the lipoprotein, towards the periphery. But cholesterol ester is hydrophobic, water repelling substance, hydrophobic, and present within the core of the lipoprotein. So that's about the LCAT. Now, what is the action of this enzyme CETP? What is CETP? Cholesterol ester transfer protein. So this CETP protein or cholesterol ester transfer protein, it's actually transfer the cholesterol ester from HDL to other low density lipoprotein. That means other lipoprotein, those who has the lesser density with respect to your cholesterol, like LDL, IDL, etc. Okay, so CETP, cholesterol ester transfer protein, it actually helps the HDL, it actually helping the HDL to transfer the cholesterol ester group from HDL to LDL or IDL. That means other lipoprotein which has the lesser density with respect to HDL. Okay, you can see this thing here, that from HDL your cholesterol ester is transferred into other lipoprotein, those who has the lesser density with respect to your HDL. Okay, and simultaneously you can see that TAG, okay, or triglyceride. Okay, so this is also coming from the LDL or IDL, that means other lipoprotein, into your HDL with the help of same enzyme. This is your CETP enzyme. Okay, so from HDL, cholesterol ester is mobilized towards the low density lipoprotein, and from other low density lipoprotein with respect to HDL, the triglyceride is moving back to the HDL, or they are transferring triglyceride towards the HDL. Okay, so this is the action of your CETP. In our